a proposal for clean energy in Red Deer, Alberta, based off an examination into the viability of specific renewable energy solutions. I am Isaac Baylor.
I'm Samantha Chong, and we are both IB students at Lindsay Thurber Comprehensive High School.
Introduction. As it stands, the problem is vast. The world's forests, oceans, and environments of all kinds are at serious risk. Climate change, driven by excessive carbon dioxide emissions, has the potential to raise Earth's temperature and displace millions of people, along with increasing the speed of our current mass extinction. The research is extensive and denotes a well-established risk. Our report seeks to help address that risk by analyzing data associated with our local community, Red Deer, Alberta, and proposing a personalized climate solution for our community. To do so, we conduct a multifaceted and unique investigation and then apply our findings in making suggestions for renewable energy implementation, not only in our own town, but across the province. So why Red Deer? Well, Red Deer actually serves as an ideal candidate to analyze. We wanted to investigate how a medium, verging on large community can change their climate impact. Red Deer meets this criteria with approximately 100,000 people. Red Deer also is sufficiently large to have data to analyze while not being so large that it has already been analyzed to pieces, like cities Toronto and Vancouver. Additionally, Red Deer has business taxes that are generally lenient, meaning it's an ideal region for startups who can exploit renewable energy opportunities that could be discovered. Furthermore, Red Deer has a relatively wealthy median income, meaning people should be able to afford slightly higher energy costs or purchase more expensive options like solar panels should we choose to subsidize them. Finally, Red Deer has a workforce trained in fields that lend themselves to a green transition. Skills such as machine repair, construction, engineering, and precision production all number among Red Deer's biggest industries. Red Deer is simply a unique opportunity. They have industrial energy needs and they have residential energy needs, the industrial ones coming from the Joffrey chemical plant just outside of the town. Finally, Red Deer is our local community, and we believe that personalized solutions created and supported by the people in the area are going to be one of the pivotal factors in tackling the massive problem that is climate change. Another factor that's important to consider is the geographical information of Red Deer. This is important when considering a proposal for clean energy. The three factors we're going to discuss are temperature, precipitation, and wind speed. As you can see in the tables displayed here, the key takeaways are that precipitation is not so severe as to severely limit the effectiveness of solar energy. The temperature is below zero for the majority of the year, and wind speed is high enough to support appropriately sized turbines.
Determining Red Deer's future energy use. As the population grows, so does the necessary energy needed to power the city. So we found that in 2017, 228.3 pentajoules was used residentially in all of Alberta. We converted that to megawatt hours, and then we divided that by the population to get a per capita energy use. We multiplied this by the predicted population in 2030 to give us the needed energy for the project. Although there are many types of renewable energy options, we chose to analyze about 5 of them as they are the most mainstream ones. So for this analysis, we used solar, wind, hydroelectric, nuclear, and geothermal. Methodology. We split our analysis into 2 parts, a more specific analysis on each of the types of renewable energies. This was done by collecting the carbon emissions, the installation cost, and the maintenance cost, and then they were compared at an equivalent scale. The second analysis was data collected from our World Data and the Red Deer government. This data was analyzed through Google Sheets using R-squared, Pearson's P, and Spearman-Rowe statistics. This data was then supported using kurtosis and skew values. Energy option comparison. So we found the cost per kilowatt hours, and we also found the carbon dioxide emitted per kilowatt hours in grams. We multiplied these together to put them on somewhat even footing. And using this, we found that wind followed by hydroelectric are the best options when considering both cost and carbon dioxide emitted. So we found the cost per kilowatt hours in dollars, and then we found the CO2 per kilowatt hours in grams. We then multiplied these together to allow for them to be somewhat equivalent in that cost per kilowatt hours and CO2 per kilowatt hours would both equally affect the outcome. And then using this analysis, we found that wind followed by hydroelectric were the 2 most optimal options. Of the previous data sets discussed showed that they were relatively symmetrical with the exception of solar energy consumption, which was skewed to the left. And then the kurtosis mostly showed a low number of outliers. Global investment per year compared to renewable growth found a strong R-squared value, meaning that the regression closely fits the data. and the Pearson and Spearman's rho values, which were larger than the respective critical values, demonstrated a strong positive correlation to a significance of 0.005, meaning that as more money is invested, the renewable energy sector will continue to grow. The skew on these datasets were relatively even, meaning they were relatively symmetrical, and they both contained a low number of outliers.
Our solution can be summarized by going over a few key points. Our analysis concluded that hydropower, while performing well, was not viable in the specific region, as the river, our only major source of hydroelectric energy generation, will be frozen for the vast majority of the year. Nuclear energy, while costly and ill-suited for neighborhood power generation, could be an excellent option for private industry. With that in mind, we'd like to suggest a small nuclear power plant to support the large industrial energy needs of the Joffre chemical plant outside the city. This has the added benefit of opening up the doors between private industry and the government for further collaboration in the renewable sector, and of providing a supplemental constant energy source for Red Deer as excess energy is pushed onto the grid. Wind and solar both performed well in our analysis, and though we were unable to include this in our report, we surveyed the local area and received strong support about implementing these two options. Due to their strong performance, geographical viability, and public support, solar and wind are intended to make up 60% of Red Deer's energy needs by the year 2030. Our intention is to gradually implement them over the coming years. Now, another key of our plan is geothermal. While not viable in the central Alberta region, it is incredibly viable in the Alberta region as a whole, and Red Deer could receive some of this power as a supplemental energy source. We'd like to suggest that Alberta tackle these resources by exploiting the thousands of megawatts of power available. We're ideally suited to collect them with our experience in the oil and gas industry. Additionally, carbon emissions are actually much lower than predicted in our report, as the specific binary cycle reactors that will be most common in Alberta have a negligible carbon footprint compared to the flash steam plants that we are able to procure data for in our analysis. Finally, the last step of our proposal is to increase our aggressive action towards net zero and eventually net negative carbon footprint. A portion of the renewable energy created would be used for active carbon capture and long-term sequestration in central Alberta. This region is extremely viable as our unique geochemical makeup of the surrounding rock formations and empty natural gas reservoirs are ideally prepared to store truly astronomical amounts of carbon. Red Deer in central Alberta could serve as a hub for Greater Alberta and as a site of active carbon capture to make up for our historically high emissions. It is important to note that our wind and solar proposal is only 60% of Red Deer's total energy use, as a portion is expected to be covered by excess generation from the Joffre nuclear plant and from geothermal energy.
Cost breakdown. It's not economically feasible for the city of Red Deer to fund this entire project, but using grants, they'd be able to fund a significant amount of it through external means. Natural Resources Canada has been known to fund between 10 and 100% of other projects. The average of all their projects was about 78%, along with the Green Municipal Fund and the Clean Energy Program also committing some, leaving the city of Red Deer to only have to commit about $11 million.
Extensions to our research. Specific data collection. Efforts should be made to reach out to the city of Red Deer and procure more detailed energy use reports in order to better customize our recommendation for the town. This will allow us to have important information, such as when the peak energy consumption is in Red Deer. Other renewable energy options. Further exploration of other renewable energy options would be an extension we'd love to include in our report. As our paper was original and the first of its kind in the region, we only focused on the big 5 methods of renewable energy production, but we did not discuss other options like biofuel or hydrogen power. Further economic analysis. While past research has been done demonstrating that Alberta would have a relatively easy transfer to geothermal energy production, we love to conduct a more in-depth analysis of more specific economic incentives that might exist, such as how many jobs would this create? We'd also like to highlight some more unique aspects of our report. Point 1 in that it is entirely original research. Our report is unique in that, unlike some of the other analysis done by the participants of the competition, no investigation has been published to our knowledge in the Red Deer region in any way, shape, or form. The foundation of our report simply didn't exist. We had to make it. Our report is additionally unique in that it's a multifaceted examination. Other reports take two variables and correlate them with a great deal of precision and specificity, but our report takes a great deal of data and conglomerates it into a large, multifaceted, unique investigation. And finally, our report is unique in that it considers carbon sequestration as a viable option of reaching net zero. To my knowledge, no other reports detail this as a method of reducing our carbon footprint.